Let's say you want to run through the steps to get the results that you need for correlation and then regression. So you will be asked a series of questions about your correlation. The first thing you want to do is run the correlation. So that's going to be found in the regression button. Click on correlation matrix. So here we're going to when you're running a correlation, it doesn't really matter the order that you put them in to get the correlation. However, if you'd like to make a plot, ideally you should put the independent variable or the item that you think is the independent variable first and the dependent variable second. Otherwise, what you want to be in the x-axis goes in the box first and the y-axis goes second. So in this case, we're proposing in our story that the number of yoga classes you take is going to be the X variable and the pain meds is going to be the Y variable. So I'm going to put them in that order. Now already we have the correlation. Now again, this matrix is just a box. If we had multiple variables listed in this box here, we'd have multiple variables across the top and down the side. And so this is kind of like a multiplication table where you're saying yoga classes correlated with pain meds. We see it's a negative correlation. So this is our Pearson's correlation here. And this is the p-value. So we see that it's a negative 0.561, and it is significant because we see that the p-value is less than 0.05. So you will be asked a series of questions about just this number. For example, is this number significant? And what is the nature of the relationship between yoga classes and pain meds? And by that question, you might want to address that the more yoga classes you take, the fewer pain meds you need to take. So, or actually a better wording would be the more classes, yoga classes you take is associated with taking fewer pain meds. Again, remember, we don't know causality, so it could be that if you're on so many pain meds, you can't take yoga classes because there's something else going on there, or it could be a third variable. So we just want to make sure that we're saying that yoga classes is negatively related to pain meds. But now we have the ability to look at the plot. So you can come down here and hit the correlation matrix. And what we should see here is yoga classes on the x-axis and pain meds on the y-axis. So if we had reversed them up in this box, then they would be reversed here. So you just want to keep an eye on that in case you're trying to visualize your data, which I always think is a good idea. So this is all the output we need for the first steps of understanding a correlation. But since it's significant, it's worth going through the regression steps. So I'm going to click OK. And now let's run the regression so we can create the equation of the line to determine, so we can use that for predicting future people. So we're going to click on regression, and then we're going to click on linear regression because that's the type of regression we're doing. So again, here we have to establish which is our dependent variable, in other words, our outcome or our y, and then our independent variable is going to go here in covariates. So we're kind of proposing that pain meds is our outcome variable, and yoga classes is our predictor variable. So that's going to go here in covariates. And so we have several things happening here. A lot of students are intimidated by this output, but this is everything that we need to answer the question about the linear regression. So I'd like to point out this part here. This is again for the model summary. Now you'll see that the negative sign has been lost here, and that's because it's doing the entire model. It's not just trying to do a paired comparison. So make sure you don't mistakenly think that this is your correlation for your pair of yoga and yoga classes and pain meds. But if we were going to find the coefficient of determination, this would be the same number because remember when you square a negative value it becomes positive. So no matter what, this positive value will still count. So here is our coefficient of determination, which is 0.315. So I could ask you some questions about that. If maybe you ask you what the number is and if you could put it in a sentence. In this case, the sentence would be 31.5% of the variability in pain meds is associated with the variability in yoga classes. And then we have this number here, the Rmse, root mean squared error. So that's our standard error of prediction. So we'll need that later when we're trying to figure out if we have the equation line, how wrong are we in using that equation to make our predictions? So here we have 1.073. So what we need to make the equation of the line is down here. So these are the two numbers that we're going to pull to make the regression equation. Now, you have to decide, based on reading this, which one is the y-intercept and which one is the slope. Now, looking at this, you can see intercept is likely the y-intercept, right? So y-intercept is labeled for you. So we now know that our y-intercept is 4.972. And then this other number is slope. And the reason I am dramatic about pointing out that this intercept is y-intercept is because it will always be labeled intercept. Whereas the label for the slope here is always going to be whatever your x variable is. So in this case, it's yoga classes. Next time it might be IQ score or something like that, whatever your x variable is. So this won't have a consistent labeling. However, the y-intercept will always be labeled intercept. So now you have to take these two numbers and put them into the equation of the line. And that can be difficult if you don't remember that the y-intercept always stands alone in the equation. So remember, the y-intercept is going to be by itself, and the slope is always going to be multiplied times the x variable. So our ultimate equation of the line here would be y hat equals negative 0.253 times x plus 4.972. Now make sure if this number is negative, then that would have been minus 4.972. Sometimes students like to ignore negative signs, and you can't do that. If they're negative, that really has to be reflected in the equation. So again, our equation of the line would be y hat equals negative 0.253 plus 4.972. So now we have all that we need to answer several more questions about this data set. For example, I could say for each additional yoga class I take, what would likely happen to, or what would be the associated change in pain meds? And you could say, well, it is predicted that the pain meds would go down would go down 0.253 doses. I might also ask, hey, my friend Joe goes to yoga 10 times a week. What do we predict Joe's pain med use to be? And so then you would plug in 10 to the x in that value. So it would be negative 0.253 times 10 plus 4.973. So that would end up being 4.973 minus 2.53. So this would be information that we could use to make predictions for future people. We could talk about what the slope means, what the y-intercept means. And then when we're asked how wrong our predictions are for our friends, we could say, well, we were off by about, give or take, 1.073. So these two analyses are all that we needed to ask and answer several questions about the relationship between our x variable and our y variable. There's the button. There it is. Button. Go away, button.